Okay, so the next thing that we have here is the rest of the properties of the inverse trigonometric functions. And part 5 of these properties is tan inverse of x is the tan inverse of x plus the tan inverse of y plus the tan inverse of y is equal to the tan inverse of x plus y over 1 minus x times y for x times y less than 1. So we have tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy for basically this condition. And also we have the tan inverse of x minus tan inverse of y, number 6, and not number 6, but this is part 1. Part 2 of this is tan inverse of x minus tan inverse of y, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y over 1 plus xy for x times y is greater than negative 1. X times y is greater than negative 1. So this is x times y is less than 1. This is x times y is greater than negative 1. And part 3 of this is tan inverse of and part 3 of this is the tan inverse of x plus the tan inverse of y is equal to pi plus tan inverse of pi plus the tan inverse of x plus y over 1 minus x times y for x times y is greater than 1 and x and y are greater than 0. So number 1 is basically the part 1 of this question is tan inverse of x plus tan inverse of y. So these are basically two angles that is equal to the tan inverse of x plus y over 1 minus xy. So you take the two ratios and combine them in this manner and give them to the tan inverse function, and it will give you basically the same result. Also, the tan inverse of x minus the tan inverse of y is equal to tan inverse of x minus y over 1 plus xy for xy greater than negative 1. And also the tan inverse of x plus the tan inverse of y is equal to pi plus tan inverse of x plus y over 1 minus xy greater than 1, x and y greater than 0. Now to prove these results, what you need to do is basically you can say that, for example, to prove the first one, for example, to prove that basically tan inverse of x plus tan inverse of y is equal to the tan inverse of x plus y over 1 minus xy for x times y less than 1, for x times y less than 1, what you can do is that you can say, for example, let tan inverse of x is equal to theta. And for example, tan inverse of y is equal to phi, for example, right? Now, this first one means that then x is equal to tan of theta, And the second one means that y is equal to tan of phi. And what that means is that now if I write tan of theta plus phi, now if I write tan of theta plus phi, so we said that is equal to tan of theta plus tan of phi, tan of theta plus tan of phi over 1 minus tan theta tan phi, that we have proved before. So that is the same thing as basically tan theta is equal to x and tan phi is equal to y and 1 minus x times y, right? 1 minus x times phi. So this means that basically tan of theta plus phi is equal to x plus y over 1 minus xy, which means that basically theta plus phi is equal to tan inverse of x plus y over 1 minus xy, and theta plus phi is equal to, theta and phi are what? Are tan inverse of x and tan inverse of y, right? So that means that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy, right? So that is that. Now that is basically the first result. Now in this result, if you substitute basically y with negative y, we have basically tan inverse of x plus tan inverse of negative y is equal to tan inverse of x minus y over 1, and negative y over here basically multiply, you will get 1 plus xy. And basically previously we said that the tan inverse of negative x is equal to negative tan inverse of x. We said that the tan inverse of negative x is equal to negative tan inverse of x for all x belonging to R. So I can write this as tan inverse of negative y, I can write it as negative tan inverse y, so I can write this as tan inverse of x minus tan inverse of y is equal to the tan inverse of x minus y over 1 plus xy. And that is basically what we wanted to show here. That is the second result that we had here. So tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y over 1 plus xy, and the condition is that xy is greater than negative 1. And I'm not really paying much attention to these conditions because they have not been discussed properly. If I get into them, I will get into trouble. Now, okay, about the third result, which was tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y over 1 minus xy. I did try a couple of things, but I couldn't prove it. So I'm not going to do tan inverse of I'm not going to try to do that. I mean I did try, but I couldn't actually do it. Now the part 6 of this is that we have 2 tan inverse of x, part 1. We have 2 tan inverse of x is equal to the sine inverse of 2x over 1 plus x squared for the absolute value of x less than or equal to 1. So 2 times tan inverse of x is equal to sine inverse of 2x over 1 plus x squared for the absolute value of x is less than or equal to 1. Number 2, we have basically 2 tan inverse of x. 2 tan inverse of x is equal to cos inverse of 1 minus x squared over 1 plus x squared for x is greater than or equal to 0. And part 3 of this is basically 2 tan inverse of x. 2 tan inverse of x is equal to tan inverse of 2x over 1 minus x squared. Negative 1 less than x less than 1, right? So now let's prove these, and then we will move into some problems. Now, to prove that basically sine inverse of is equal to 2y. So now if I let to prove these, if I let basically tan inverse of x equal to y, then if I let tan inverse of x is equal to y, then x is going to be equal to tan y. Now basically sine inverse of 2x over sine inverse of 2x over 1 plus x squared is equal to sine inverse of and basically x is equal to tan y, so that's 2 times tan y over basically 1 plus tan squared y, which is the same thing as 2 times tan y 1 plus tan squared, which is basically sine of 2y, because we said over here in the previous videos, so I'm not really sure where we were actually. I think it was somewhere over here. So we said that tan of 2x, or we said that sine of 2x is equal to 2 times tan x over 1 plus tan squared x, right? So we said that basically sine of 2x is equal to 2 times tan x over 1 plus tan squared x, right? Then that is basically for x is not equal to n pi plus pi by 2, where n belongs to the set of integers. So that's basically what we proved before, which means that so over here I have the exact same thing, 2 times tan y 1 plus tan squared y. I can write it as sine of 2y. I can write this as basically sine inverse of sine 2y. Now the sine inverse of sine of 2y is equal to 2y, and y is equal to tan inverse of x, so that is equal to 2 times tan inverse of x, right? So 2 times tan inverse of x is equal to this thing over here. So I can write 2 times tan inverse of x is equal to sine inverse of 2x over 1 plus x squared. That is the first result over here, and that is the condition here, is that the absolute value of x has to be less than or equal to 1. That is the first one. Now the second one that we have here is well, we will discuss that in just a few moments. Okay, so now to take care of the second part of this question, we have 2 tan inverse of x is equal to cos inverse of 1 minus x squared over 1 plus x squared for x is greater than or equal to 0. So basically to prove that tan inverse 2 times tan inverse of x 2 times tan inverse of x is equal to cos inverse of 1 minus x squared over 1 plus x squared for x is greater than or equal to 0. Basically you can, if I say that basically let, for example, tan inverse of x is equal to y, then that means that basically x is equal to tan of y. Right? X is equal to tan of y. Now I can say that basically I can say that the cos inverse of I can say that further the cos inverse of basically 1 minus x squared over 1 plus x squared is equal to the cos inverse of 1 minus x squared, so x is equal to tan of y. So you have 1 minus tan squared of y, and 1 plus tan squared of y. And that is one of the that is a trigonometric ratio related to some angle that we discussed before, which was some multiple of x, which was basically that's a trigonometric ratio related to the cos of 2x. So that's cos of 2x. We said that it's equal to 1 minus tan squared of x over 1 plus tan squared of x. And if I take this into consideration in the context of this problem, that is going to be equal to the cos inverse of basically cos of 2y, which is going to give me 2y. And 2y is equal to basically 2 times tan inverse of x. 2 times tan inverse of x, right? Now, 2 times tan inverse of x is equal to this, so therefore 2 times tan inverse of x is equal to the cos inverse of 1 minus x squared over 1 plus x squared. That is for x is greater than or equal to 0. Okay, so now to prove the third part here, we said that basically to show that, in order to show that the 2 times tan inverse of x is equal to tan inverse of 2x over 1 minus x squared for negative 1 less than x less than 1. So you have again, I can say that basically tan inverse of, if I set, for example, let tan inverse of x is equal to y, which means that x is equal to tan of y. Now, if I further write that tan inverse of 2x over, that is tan inverse of 2x over 1 minus x squared. So 2x is equal to 2 times, that is going to be equal to tan inverse of 2 times tan y, 2 times tan y, 1 minus tan squared of y. And we said that basically tan of 2y, so you know that basically tan of x plus y is equal to basically tan x plus tan y, tan x plus tan y tan y 1 minus tan x tan y, right? Now if in this formula, if I substitute y with x, we have tan of basically x plus x is equal to tan of x plus tan of x over 1 minus tan of x, and that is the same thing as 2 times tan of x over 1 minus tan squared of x, and that is equal to tan of 2x. So tan of 2x is equal to 2 tan x over 1 minus tan squared x, right? So I can write this as tan inverse of tan of 2y. Tan of 2y is equal to 2y, which is equal to y is equal to tan inverse of x, so that is 2 times tan inverse of x, which means that basically 2 times tan inverse of x, which means that 2 times tan inverse of x is equal to tan inverse of 2x over 1 minus x squared, right? And that is for x's between -1 and 1. -1 is less than x is less than 1. Now what we need to do now is that we need to do a couple of examples. Actually, first of all, we need to summarize, and then we need to do a couple of examples. So let me first do the summary here. So number 1, basically in number 1 we said that the sine inverse of 1 by x, is equal to cosecant inverse of x for x is greater than or equal to 1 and or x less than or equal to -1. Number 2, we said that the cos inverse of 1 by x is equal to secant inverse of x, for x is greater than or equal to 1, or x is less than or equal to -1. And part 3 of this, we said that tan inverse of 1 by x is equal to cot inverse of is equal to cot inverse of x for x's greater than 0. So this is the first set of results that we talked about. This is the first set of results that we talked about. The second set of results, so this I'm going to call 1. The second set of results is basically sine inverse of, we said that sine inverse of negative x is equal to negative sine inverse of x. Negative sine inverse of x for x's belonging to negative 1, 1. And we said that the tan inverse of negative x, and we said that the tan inverse of negative x is equal to negative of tan inverse of x, tan inverse of x for x's belonging to the set of real numbers. And we said that the cosecant inverse of negative x, the cosecant of negative x is equal to negative cosecant inverse of x for the absolute value of x greater than or equal to 1. This was the second set of results that we talked about. Now the third set of results were basically number 3. We said that cos inverse of negative x, we said that the cos inverse of negative x is equal to pi minus cos inverse of x, pi minus cos inverse of pi minus cos inverse of x for x's belonging to the interval negative 1, 1. And we said that the secant inverse of negative x is equal to pi minus secant inverse of x for the absolute value of x greater than or equal to 1. And we said that the cot inverse of negative x is equal to pi minus cot inverse of x for x belonging to R. Right? So that is the third. So basically for sine, tan, and cosecant, the sine inverse of negative x is equal to negative sine inverse of x, negative tan inverse of x, negative cosecant of x. For cos, secant, and cot, the cosecant of negative x is equal to pi minus cosecant of x, pi minus secant inverse of x, and pi minus cot inverse of x. That is another result that I actually do not remember if probably it's not really possible that we could have missed this, but well, that is another thing that we talked about. Hopefully. I cannot go back in the video, but now, number 4, basically in number 4, we said that the sine inverse of x plus cos inverse of x, number 4, we said that the sine inverse of x plus the cos inverse of x is equal to pi by 2, for x's belonging to the interval negative 1, 1. And we said that the tan inverse of x plus the cot inverse of x, is equal to pi by 2 for x's belonging to R. And we said that the cosecant inverse of x plus the secant inverse of x is equal to pi by 2 for the absolute value of x greater than or equal to 1. That was number 4. That was number 4. Now for number 5, we have, in number 5 what we discussed was let me actually do this over here because we have this space, so let's use it. For number 5, we said that tan inverse of x plus tan inverse of y, we said that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y over 1 minus xy for x times y less than 1. And also we said that tan inverse of x minus tan inverse of y, we said that the tan inverse of x minus tan inverse of y is equal to tan inverse of the tan inverse of x minus y over 1 plus xy for xy basically greater than 1. And we said that tan inverse of x plus tan inverse of y, and we said that tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y over 1 minus xy for x times y greater than 1 and x and y greater than 0. So tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y over 1 minus xy for xy greater than 1 and x and y greater than 0. And part 6 that we discussed here was, and the last part that was, the last part, which was part 6, we said that basically 2 times tan inverse of x, 2 times tan inverse of x is equal to sine inverse of 2x over 1 plus x squared for the absolute value of x less than or equal to 1, and 2 tan inverse of x, and 2 times tan inverse of x is equal to cos inverse of 1 minus x squared over 1 plus x squared for x is greater than or equal to 0. And also we said that basically 2 times tan inverse of x is equal to tan inverse of 2x over 1 minus x squared. 2 times tan inverse of x equals tan inverse of 2x over 1 minus x squared for negative 1 less than x less than 1. So that's the whole thing that we talked about. Now what I'm going to do is that I'm going to just simply make a screenshot here, and we will get to the problems. So I'm going to call this inverse trigonometric functions properties, and save it on desktop, and that is basically that. So what I'm going to do is that I'm going to end this video here. In the next video we have a couple of examples, example 3, 4, 5, 6, 7, and then we have a couple of exercises, actually a whole bunch of exercises, and then after that the whole chapter is We have some miscellaneous examples and exercises, and then the chapter is done. So I'll see you in the next video, and thank you.